Okay, welcome everybody to this video, the final of the videos within the sort of FX foreign exchange section of the economics material within CFA Level 1, and it's an important one from a computational point of view. It's highly likely and probable that you may get a question on this, the computation of forward rates, and this is important also because, or helpful also because, it ties in very nicely with what you have already done or will be doing within derivatives. So a lot of benefits from watching this video. If this is your first encounter with the Let Me Explain YouTube channel, then a warm welcome. Please consider subscribing. And also, please consider supporting the channel to get access to a wider base of video material, videos like these. Okay, now I'm going to work through this topic purely with examples, sort of very minimum theory, minimal amounts of theory, just examples. As many of you know, I am based in Poland, so let me present to you what is more or less the current exchange rate for my currency, the Polish zloty, that's the PLN, against the euro, and when I checked it was 4.27081, so quoted with a lot of detail down to the fifth decimal place here. So that's the spot rate. That's the rate at which you could do an exchange of euro for zloty, basically this many Polish zloty per 1 unit of the euro. Please appreciate the convention that CFA Institute uses. This is always the base currency, that's the price currency, and it's always how many units of this one per 1 unit of this one, irrespective of how actual conventions work in the market. Now, what if I told you that we can also have and see a 3-month forward rate, so a rate at which you could lock in an exchange that would take place in 3 months' time, and the dealers quoting it would be showing something like 4.28342. I just made that up. It's very hypothetical. Okay. Now, what you may have to do is, and if you get this kind of question, it's dead easy. That's not really what this video will be about. But what you may have to do is express this forward quote in a manner which is more common, that is, express it in points or pips. So let's try to do this. Let's actually state that this is going to be more commonly expressed not as an actual exchange rate, like if you agree with the dealer to do today for settlement 3 months away from now, the exchange rate you can lock in the forward rate is 4.28342. Okay, that's one way of expressing it, but more commonly this forward rate is going to be expressed in points or quoted in terms of points or pips. Now, points, what we actually are talking about is something known as forward points or swap points. So this is really easy. If you have to convert this into points, you've got to basically measure the difference between this exchange rate, the forward rate, 4.28342, and this spot rate, so the rate at which one could do an exchange that would take immediate effect, 4.27081. Here's my calculator. This should be the easiest thing in the world, assuming I don't make a mistake when keying these in, minus 4.27081. Okay, and it seems that these points, forward point swap points, are plus, or the difference is plus 0.01261. It's important to note the sign because they can either be positive or negative. But to be honest, we don't leave it like that. When you express things as forward points or swap points, you scale up. Typically by 4 decimal places, unless you're dealing with the yen, then it's 2 decimal places, but that comes from conventions for quoting a specific currency, like the yen. In the exam, just scale up by 4 decimal places. So kind of take this, but move it up 4 places to the left. And I mean, ultimately, what this will result in is the same as multiplying by 10,000. Okay, so we've got 4 zeros there. And it should, I mean, I've got the number on my calculator. If I multiply by 10,000, oops, I did it too much, sorry, 0.01261 times 10,000. I had 1 additional 0 too many. Okay, you get 126.1 points, positive points. Okay, let's not lose track of that. So in reality, it would be more common for a dealer to say, this is the spot rate, but the 3-month forward rate isn't this, it's actually plus 126.1. And what you need to do then is add those points on to the spot rate. So you know, that's the way the market kind of more typically functions. So let's just quickly do this, kind of reverse engineer this. If they ask you, what's the forward rate for exchanging euro into zloty, right? Polish zloty, you would go, okay, I've got the spot rate. They've given me the spot rate, 4.2781. Take it. And if they provide you with the swap points, assuming they are positive, then you obviously add. If it's negative, you have to. If they're negative, you have to deduct. But here it's you know, we just add the forward points, but don't add 126.1 to 4.27. You'll get a wacky number like, you know, 130. That's not the exchange rate. Because those forward points are always scaled up by 4 decimal places, unless it's the yen, then 2, you have to divide them by 10,000. So effectively, you add 126.1 points positive over 10,000, and let's see what you get. So 4.27081 plus 126.1, but divided by 10,000, and you get 4.28342, which was the original 3-month forward rate that I wrote down. So I've just given you kind of 2 ways to think about it, either in points or as an actual forward rate. But both quotations are used, and you should be quite flexible, sort of, and agile to work from one to the other. Okay, this scale, or the number of swap points, the size of that, what you have to add or deduct, what typically happens is it increases with maturity. So if that's the spot rate, right, the number of points you either have to add or deduct, it kind of grows with maturity. That's how I chose to depict it. So if you were quoted at 1 week forward rate, it would be less, typically less swap points than for a 3-month. A 6-month would be even more, and 12-month or further out into the future would be even higher. That works both ways. So if you're adding swap points, you add more, but if you're deducting swap points or forward points, it also you kind of have to deduct more as well. The reason for this will become apparent in a second when we move to sort of the underlying logic of where forward rates come from, but it comes from the fact that the forward rate is a function of the difference in interest rates between the two currencies. In this case, it would be the Polish zloty and the euro, but also that interest rate differential is scaled for time. So the longer the time to the expiry or settlement of the forward contract, the more that interest rate difference kind of impacts the forward quote. Right. Let me also state, right, because this does get picked up on in the curriculum, that forward points may also be expressed as a percentage of the spot price. However, that approach is definitely less common than just quoting the points. So in this case, you could be told, well, if the swap points are plus 126.1, express them as a percentage of the spot price. So in that case, you'd have to scale them down by 10,000 and then relate the result to the current spot price, and that spot price was 4.27081. Sorry, 4.27081. Now this is going to give some, daft, silly small number, but 126.1 divided by 10,000. Remember that the fact that swap points are quoted as something like 100, it's just for us, it's easy for us to interpret, look at then 0.0 something, but whenever you try to work with them as numbers, you always have to do this scaling down to their original size. Divided by 10,000, and now I divide the result by 4.27081 equals, let me just check if I haven't made a mistake with the zeros. 126.1 divided by 10,000. When you keep talking and doing something on the calculator, that may easily, be the grounds for a mistake there. Divided by 4.27081. No, I think that's fine. Okay, so it's 0.00295, and if you were to express this as a percentage, I hope you agree this would be a positive, but 0.295 more or less of a percent. Okay, so easily can use that to compute the forward rate, because the forward rate is going to be higher by this much than the spot rate. So just practice with the questions that are in the examples in this chapter. Have a look at the end of chapter problems as well, and just make sure you're comfortable with this. It's just pure numbers. It's not difficult at all. Now, what is a little bit more conceptually difficult, but hopefully I'll make this easy for you, is where this forward rate comes from. And I already said, when I drew this extending funnel here, that the forward rate is a function of interest rate differences between the two currencies, and those interest rate differences get scaled for time. Good. So let me give you an example. Now, your book talks about this for about 4 pages. I'm going to make this, or attempt to make this much more concise and much more intuitive. Imagine you've got an investor who's based in the Eurozone. So, Eurozone investor, and therefore for them, the euro will be their domestic currency. Now, I'm intentionally or consciously using notation that your book also uses. So D is going to stand for the domestic currency from the point of view of the investor, right? And let's stick to my home currency. That's the Polish zloty, the PLN. But from the perspective of the Eurozone investor, that's going to be a foreign currency, F. Now, the exchange rate, the spot S exchange rate between the foreign currency and the domestic currency. In other words, the exchange rate of the PLN to the euro which I gave you before up here, the spot rate, the S rate, spot rate, was 4.27 something. I'm just going to round it up to 4.27. We don't need so much detail, at least not in this little sort of conceptual example. Okay, having the PLN, the Polish zloty, above the euro in terms of distraction means this is how many Polish zloty you get per €1 per euro. Okay. Now, what's also going to be important are the interest rates in both currencies. Now, the interest rate in the Polish zloty is typically higher than in the euro by 1-2 percentage points, sometimes a bit more. So I'm going to actually maintain that practical, actual real difference, although I'm not going to use the precise numbers as they are. So I'm just going to assume that the exchange rate in the domestic currency, remember the domestic currency is the euro from the perspective of this example, is going to be 3%, but the interest rate in the foreign currency, that's the Polish zloty, is going to be 5%. Now, typically in most financial sort of formulae, when you see RF, you think, okay, risk-free rate of interest or something like that. But in this case, both are risk-free rates. So think about rates you could get on government bonds or at the central bank, something like this. It's just RD means the rate in the domestic currency, RF the rate in the foreign currency. And my question is going to be, and this is a question you may very well get in the exam, what is the forward rate between the F and the D? So the forward rate for the Polish zloty against the euro, let's say, 1 year out into the future, the 1 year or 12-month forward rate. Okay, now, in order to appreciate how this works, I'm going to draw some illustration. So it's going to start over here on the left-hand side with an assumption that the euro-based or eurozone-based investor, seeing that the interest rate in the euro is definitely lower than it is in the Polish zloty, will actually borrow where it is cheaper to borrow. So let's say that this investor borrows a very small amount, €100 for 1 year. Obviously, the assumption is they can do this at 3%, which is not necessarily true for most investors because they can't necessarily borrow at the risk-free rate, but this one can. So 1 year later, if they borrow 100 over here, they'll need to pay back, or this will grow to 103, which will have to be returned. Okay, so going across to the right-hand side means, going forward in time. But they take this freshly borrowed €100 and they convert this into the Polish currency, the PLN, at the prevailing current spot rate, 4.27. Thus, receiving 427 Polish zloty. And the reason why they do it is because this money over in Poland can be invested at a much better risk-free rate of 5%. So, just in the same way as this amount, this borrowed amount grows into 103 by multiplying by a factor of 1.03 to arrive at what will have to be returned. In the same way, we can take this and multiply it by 1 plus the interest rate in Poland. So 5, an assumed hypothetical 5%, and the 427 invested in Poland will grow at 5%, so times a factor of 1.05 to reach 448.35. Now, you see, this is something the investor sees right now on their screens. They can see the rate at which they are able to borrow. They can see the rate at which they are able to invest in that foreign, place, Poland, right? They can see all of these things and take advantage of them. But the question is, what's going to be the exchange rate in the future to come back from Polish zloty into the euro? And of course, this is something that can be locked in using forward rates. So imagine just for a moment that the dealer is quoting you a 1 year forward rate, i.e. a rate that will allow you to make the comeback, and it is miraculously the same as the spot rate, 4.27. And you can already today, at the very outset, at the start of this whole strategy, let's call it, lock that in and confirm it. If you could do that, if you could find a dealer that shows you 4.27 for the comeback, that would be brilliant, because those future Polish zloty, 448.35 of them, if you divide by 4.27, that would give you not 103, but 105. Okay, you've got to return 103, but the currency conversion would give you 105, meaning you would earn a profit of 2. It's risk-free because all of these things could be locked in instantaneously by trading in the market at a single point in time. This is a risk-free investment. This is supposed to be a risk-free investment. Everything here is risk-free, and this would be a pure so-called arbitrage profit, because you didn't even invest any of your own money to make that profit. It was risk-free, and it didn't involve any of your own money. So if you found such an opportunity, why do it on a scale of 100 euros? Add a few zeros, as many as you can, borrow as much as possible, and pile this into the strategy. Unfortunately, what would happen is, if you try to borrow a lot, the interest rate in the Eurozone would go up, if you try to borrow too many euros. If you try to invest too many of those euros converted into Polish zloty in the Polish economy, the interest rate in Poland would drop, because Poland will be flooded with money coming from the Eurozone to take advantage of the interest rate. And in any case, the more Polish zloty you try to buy on the spot market, the less you're going to get. And something similar happens on the other side. And what I'm basically trying to say is that arbitrageurs, people or entities or algorithms who spot such opportunities, which are a result basically of mispricing, will work through these types of strategies and force the opportunities to basically to close and dry up. In other words, if the market is in equilibrium, you will not find 4.27 as the quoted exchange rate. If the market is in equilibrium, meaning nobody has really an incentive to move in any way, what should be true is that the forward exchange rate for the PLN against the euro is going to be reflective of this amount, 448.35 divided by 103. So you should be able to lock in a rate which unfortunately returns you or gives you exactly the amount of euros that you will need to pay off your original borrowing. So that's more or less 4.353 or so, more or less, yeah? Now, that's the problem with forward markets. If you try to lock everything in, including the rate which you'll use for the comeback, all the magic of investing at the higher rate in a higher rate currency is going to be eaten away, or it will disappear effectively. So, as you can see, this forward rate, or the implied forward rate as we often call it, was really a function of the spot rate, 4.27, but then multiplied by 1 plus the interest rate in Poland, divided by 1 plus the interest rate in the Eurozone. And obviously, these rates here could be scaled for time. If I told you this is not 1 year, this is 6 months, you'd have to scale everything for time. So multiply each of those rates, the 5 and the 3, scale it by half effectively, or by 2, by a factor of 2. But look, 4.27 times 1.05 divided by 1.03 gives, well, as you can see, it gives 4.35, the same number as before. The formal way of writing this down, and this is what takes many pages in your book to explain, is that the forward rate between a foreign currency and a domestic currency, and of course that depends on what is foreign and domestic for the given investor, is equal to the spot rate between those currencies multiplied by 1 plus the rate of interest in the foreign currency. In our case that was the Polish one, which was earning 5, divided by 1 plus the interest rate in the domestic currency. That's pretty much the same thing as up here, but let me note that, and once again stress, that you may be asked to scale, you may be required to scale these for time, because you may be asked not for the 1-year rate, but a 6-month rate or a 3-month rate, in which case you would have to take each one of those rates, the 5 and the 3, and scale them by dividing by 2 or by dividing by 4 before you add them to the 1. Don't scale the 1.05, scale the 5 or the 3, So the forward rate is a function, let me stress this again, of the interest rate difference, the differential scaled for time. I'm going to write this down because it's an important result. The forward rate, the exchange rate, is a function of the interest rate difference. So interest rate differential, as it is formally known, a differential, but scaled for time. Good. And in our case, the difference between the two interest rates was around 2 percentage points, 2% or 2 percentage points. And what people sometimes do, and this may save you time in the exam, is kind of, if you want a quick and dirty way of computing what should be the forward rate, instead of going through all of this 1 plus business, just take the spot rate, 4.27 as it was, and multiply by 1.02, and that will give here 4.355. It's an approximation. The proper way to do it is this. But when I was taking the exam, the curriculum even said, well, I think it did, or maybe it was said somewhere else, this can be used as an approximation, and sometimes it will work and save you time. Of course, if the answers are very close, you have to rely on the proper approach. Now, an important thing here is the conclusion that, remember, in my case, Poland had the higher interest rate. The euro had the lower interest rate. And what we started off with was a spot rate. This was the price of 1 euro expressed in Polish zloty. This is how many Polish zloty you have to pay for 1 euro, or what 1 euro converts into in terms of Polish zloty. And the forward rate, as you can see, is higher than the spot one. So the price of the euro, the price of a single euro in the forward market is higher than in the spot market. And that's a very important thing to appreciate. So the currency with the higher I over R. This is my way of abbreviating interest rate. I've been using it for ages, so you may actually start doing it as well, because it's a nice way of doing it. I over R means interest rate will trade at a discount in the forward market. And conversely, the currency with the lower interest rate will trade at a premium in the forward market. So in our case, the currency with the lower interest rate was the euro. And as you can see, in the forward market, locking in the conversion to buy the euro in exchange of Polish zloty means it costs more PLN to get the euro in the forward market than it does in the spot market. By the same token, or the mirror sort of argument here is, whilst in the spot market, 1 euro can get you 4.27 zloty, in the forward market, 1 euro gets you more Polish zloty, which means the Polish zloty, the currency which had the higher interest rate, has depreciated. It trades at a discount because, the conversion, it's become cheaper. You can get, with 1 euro in the forward market, you can lock in more Polish zloty. Obviously, currencies are a bit confusing sometimes, to think about what's appreciated, what's depreciated, but you have to get your head around this. Now, an important sort of conclusion, once again, in your curriculum takes a lot of time or a lot of space, but hopefully I'll save you some time here. The forward exchange rate, so the forward rate in currencies, is really only a product of this computation that I showed you. It's a product of the so-called arbitrage equation, or the arbitrage argument, and more on arbitrage computation in derivatives, actually. So the forward points, that is the difference between the spot rate and the forward rate, is simply, influence or a product of the interest rate differential plus time. The longer the time, the bigger that difference becomes. And we really shouldn't interpret this, and your book kind of goes that some people do, and sometimes it's okay, but don't do it, at least in the CFA exam. Don't think that this is the market forecast of where exchange rates will go. A good example of this, is something that's talked about quite a lot right now, the so-called carry trade. The carry trade is all about borrowing in a low-rate currency and investing in a higher-rate currency. And for ages, investors borrowed money in the Japanese yen and converted into other currencies like the US dollar, which had a better interest rate, and invested there. Now, if the forward rate was anything to go by, the exchange rate should have changed in such a way that the yen should have depreciated and this should have ultimately eaten all the gains from investing in a higher rate currency. But for ages that didn't happen. The exchange rate remained fairly flat, so the spot rate didn't really follow what the forward rate was suggesting, because it's just a product of an equation, not a forecast.